Hi, all of you. So far, we have discussed the types of corrosion. So now let us discuss the corrosion control. The corrosion types are so numerous, mechanisms are also so different, and conditions. Hence, no single method can be used to control all possible corrosion cases. The choice of a control method depends on the nature of metal, nature of corrosion environment, and similar other factors. Some of the important methods used in curtailing corrosion of metals are protective coatings. Second one is cathodic protection. So let us take protective coatings. So what are protective coatings here? So application of protective coating is one of the important method of corrosion control. The protective coating protects the metal from corrosion by acting as a barrier between the metal and the corrosion environment. The main types of protective coatings applied on the metal surfaces are: number one is metal coatings, and second one is inorganic coatings. So let us take metal coatings or metallic coatings. So metallic coatings, what are metallic coatings actually here? Deposition of a protective metal over the surface of a base metal. Here, base metal is the metal which you want to protect. The metal which you want to protect is called as base metal. So that is why deposition of a protective metal over the surface of a base metal is called metallic coatings. Metallic coatings are applied by electrodeposition, flame spraying, cladding, hot dipping, diffusion coating, and vapor deposition techniques. From the corrosion point of view, again, metallic coatings can be divided into two classes. A, anodic coatings, and second one is cathodic coatings. So under A, anodic coatings, okay, here under anodic coatings, so what we can discuss? Anodic coatings are produced by coating a base metal with more active metals, so which are anodic to the base metal. For example, iron is coated with anodic and more active metals such as zinc, magnesium, and aluminum. So one of the important method or one of the important characteristics of this coating is that even if the coating is ruptured, the base metal does not undergo corrosion. The exposed part of the metal is cathodic with respect to the coating metal, and the coating metal preferentially undergoes corrosion. The protection is ensured as long as the anodic coating metal is still present on the surface. Therefore, anodic coating is also known as sacrificial coating method. So that is why here sometimes iron is coated with zinc, sometimes iron is coated with magnesium, sometimes iron is coated with aluminum. So all these are comes under anodic coatings. So one of the important method under anodic coatings is galvanization. So galvanization is a familiar example for this anodic coatings. So here let us take so here the summary of corrosion control and how many types are there till now what we have discussed here. So when you take corrosion control, under corrosion control protective coatings, number one, second one is cathodic protection. So under protective coatings, then again protective coatings have been subdivided into two categories: metallic coatings and inorganic coatings. Under metallic coatings there are two types again: anodic coatings and cathodic coatings. Only for you, anodic coating is there, that too galvanization is there. Then under again inorganic coatings, only okay anodized coatings is there, or anodization of aluminum is there, no phosphate coatings. So this is about corrosion control. Now let us take the important one is galvanization method. That means galvanization process. The question may be asked on this galvanization is: what is galvanization? Explain the steps involved in galvanization diagrammatically and mention its applications. First of all, what is galvanization? So look at this slide here, galvanization. So galvanization is a process of coating a base metal surface or iron metal surface with zinc metal is called as galvanization. Galvanization is carried by hot dipping method. The following steps involved in this galvanization process. First, step number one is the metal surface which you want to coat with zinc. is washed with organic solvents such as acetone, carbon tetrachloride, benzene, toluene. So why we have to wash the metallic surfaces with organic solvents? To remove organic matter on the metallic surfaces. Second step is second step is the metal surface is washed with the dilute sulfuric acid to remove rust and other deposits. Then third step is the article is then dipped in a bath of molten zinc. Molten zinc means so liquid zinc, fused zinc. So maintained at 430 degrees centigrade and covered with a flux of ammonium chloride. So the flux is added to prevent the oxidation of molten zinc during coating. So the last step is the excess of zinc on the surface is removed by passing through a pair of hot rollers which wipe out the excess of zinc coating and produces a thin coating finally. So let us take all these steps diagrammatically here. See what we have taken. Iron sheet we have taken. It is washed with organic solvent taken in a tank, and again it is washed with dilute sulfuric acid, and it is dipped in a bath of molten zinc chloride. Okay, bath then it is ammonium chloride is also added as a flux, and then afterwards it is heated at 430 or 450 degrees centigrade, and excess of zinc coating is will be wiped out by passing the iron sheet through a pair of hot rollers. Finally, we will get galvanized iron or galvanized sheet. Application, sir. Application: galvanized articles are extensively used to protect iron in the form of roofing sheets, fencing wires, buckets, bolts, nuts, nails, etc. However, galvanized articles are not used for storing or preparing foodstuffs, since zinc dissolves in dilute acids and producing toxic zinc compounds. That is why zinc coated particles are not used for storing foodstuffs. So this is about the galvanization process. So next, let us take the anodization of aluminum. It's very important. Anodization of aluminum and galvanization also is very important one. So first here, inorganic under inorganic coatings, anodization will come here. So inorganic coatings are generally chemical conversion coatings. Means one of the surface layer of metal is converted into a compound which acts as a barrier between the underlying metal and the corrosion environment. So inorganic coatings are applied by chemical dip, spraying, by electrolytic methods. Under these anodized coatings, phosphate coatings and anodized coatings are employed. So under these inorganic coatings, only for you anodization is there, or anodization of aluminum is there. So anodized coating is generally produced on non-ferrous metals like aluminum, zinc, magnesium, and they alloys by anodic oxidation process. Means aluminum, one of the layer of one of the outer layer of aluminum is converted into its metallic compound. That metallic compound acts as a barrier between the metallic surface and the corrosion environment. So same way here, zinc also, one of the outer layer of zinc, okay, is converted into metallic compound. Magnesium also converted. So by anodic oxidation process. What is anodic oxidation process here? In which the base metal is made as anode. Base metal means whether uh, if you want to take aluminum, aluminum will be as made as anode. Zinc, magnesium, so likewise. So and lead is used as cathode in an electrolytic bath of suitable composition by passing direct current. The most commonly used baths are chromic acid bath, sulfuric acid bath, phosphoric acid bath, etc. So why these baths are used? Bath is nothing but the combination of chemicals which are taken for a particular coating. that is called as chemical bath composition for a particular coating. So that is why here, for example, in the anodization of aluminum, one of the outer layer of aluminum is converted into monohydrated aluminum. Hence, the aluminum will be protected. So under this process, see, aluminum is taken as anode, and lead is taken as cathode, or stainless steel can be taken as cathode. Then bath, what kind of baths are used? Chromic acid bath can be used, sulfuric acid bath can be used, phosphoric acid bath can be used. So temperature 35 to 40 degrees centigrade. Thickness of the deposit is controlled by adjusting the current and then bath composition also. The reactions involved during anodization of aluminum are at the anode. At the anode means aluminum oxidizes and it forms 6 electrons. And at the cathode, hydrogen is liberated. So overall reaction when you observe 2Al plus 3H2O useless to Al2O3 plus 3H2. Actually here during the during the anodization of aluminum, oxygen gas is liberated at the anode. This oxygen gas combines with aluminum to form Al2O3, which is slightly porous actually, So that is why it is sealed by dipping in hot water. So when you seal it by dipping in hot water, then Al2O3 gets converted into monohydrated aluminum monohydrated aluminum oxide. So this monohydrated aluminum oxide acts as a barrier between the metallic surface and the corrosion environment, thereby protecting the aluminum metal for a long time. So here applications. So here applications are anodized articles are used as soap boxes, tiffin carriers, window frames, etc. So this is about anodization of aluminum. So next, let us take okay, and let us discuss about cathodic protection in the next class. Okay, thank you.